A problem that we actually should have already covered, but just to make sure that we understand the idea. When we say the greatest common factor of two or more numbers, we're looking for a factor, the biggest one, that will divide 4 and divide 6 in this case. And if we had more numbers, the same factor must divide 4, divide 6, and divide any other number that's there. So if we think about it, this no longer requires the factor to just be prime. It can be any factor as long as it is a factor. So in the case of 4, it's 1, 2, and 4. In the case of 6, it's 1, 2, and 6. Or, sorry, 1, 2, 3, and 6. The biggest factor that they share in common is going to be 2. Now, sometimes if you try to find these by hand, if the numbers are small, you might not have too difficult of a time. However, when the numbers start getting bigger, you definitely want to apply prime factorization to it. And essentially, you just look for what's shared, what is overlapped, right? So in this case, this is 2 squared, and this is 2 to the 1, 3 to the 1. So all they share is just 1, 2. They don't share any 3's, and they don't have any other prime factors in common. So in this case, we're going to say the greatest common factor is 2. The greatest common factor of 6 and 9, well, this is 2 times 3, this is 3 squared. So they share 1, 3 in common, right? And so the idea is that 3 will divide 6, and 3 will also divide 9, and it is the biggest factor that's there. So if we tried using, for instance, 6, 6 will obviously divide 6, it divides itself, but 6 will not divide 9 evenly. You'll be left with 1.5. So basically, that's not going to work. So in this case, the greatest common factor is 3. The greatest common factor of these two, this is 2 squared, this is 2 to the 1, 5 to the 1. They only share 1, 2 in common. That's it. They don't share any 5's. Over here, 6 and 10. Again, they're giving us some pretty easy questions, so we'll thank them for that. But as it gets slightly more difficult, let's take a look, right? So of 10 and 16, all right? So this is 2 times 5, and this is 2 to the 4th power. All they share in common, again, is still just 2. And they do not share any 5's, and they don't have any other prime factors, so they definitely can't share any other prime factors, right? So it's going to be 2 again. In this case, this is 2 times 2 times 3, and this is 2 times 3 times 3. They will share in common 1, 2, and 1, 3. So in that case, 2 times 3 is 6, and we can double check this. So 12 is divisible by 6, it leaves 2, and 18 is also divisible by 6, it leaves 3. So in that case, I will say 6 is the greatest common factor. All right, out of these two, again, this is 2 squared times 5, and this is 2 squared times 3. Guess what they share in common? 2 squared. 2 squared is 4. So we can double check it. 20 is indeed divisible by 4, and 12 is also indeed divisible by 4. And 4 is the greatest factor that these two numbers share in common. So out of these two, this is 2 times 2 times 3, and this is 3, so they share 3. As we go on from here, this is 2 squared times 5, and this is 2 to the 4th. So again, they're showing 2 squared, which is 4. Over here, this is 3 times 5, and this is 2 times 7. They don't share anything in common, so the greatest common factor between them will be 1, right? Remember, 1 is neither prime nor composite. It's just a positive integer, and 1 is a factor of every positive integer. So 1 divides 15, and 1 also divides 14. So again, when they don't have any prime factors in common, the greatest common factor will be 1. Now we have 3 numbers going on here. This is 2 cubed, and then 2 times 3 squared. So really it just shares a 2 in common, right? As we go further, this is 2 times 5, this is 2 times 2, this is 2 times 2, so they only share 1, 2 in common, right? The 10 only has 1, 2. and the 4s obviously don't have any 5s, so the greatest common factor is 2. When we keep going over here, this is 2 times 5, this is 2 times 3 times 3, this is 2 times 2 times 5. Again, the most that they share in common is just 1, 2. 10 doesn't have any 3s, 18 doesn't have any 5s, and 10 only has 1, 2. So there we go. It's very important to actually do the prime factorization of these numbers because it'll just make your life so much easier. This is 3 times 5, this is 2 times 3 times 3, so at most at this point they can only share 3 in common. And look, 9 has 2 3s, but 15 only has 1 3, so what we're going to do is say we have 3. Greatest common factor is 3. Going on from here, this is 2 times 3, this is 2 times 3 times 3, and this is 2 times 7. No 3s here, but they all share at least 1, 2, so there we go. 3 times 5, this is 2 times 3 times 5, so far they're sharing the 15. And 41 we have to check, so it's not divisible by 2, because it's not even. It's not divisible by 3, 4 plus 1 is 5, not a multiple of 3. It's not divisible by 5 because it doesn't end in 0 or 5. And then we can try 7, but that's not divisible by either because that's there. So really 41 is prime. A prime number will only have 1 and 41, in this case, as its factors. And so our greatest common factor will just be 1. As we continue from here, again, this is 3 times 5, so 9 times 5 is 45. This is 2 times 3 times 7, and then this is just the 3. So at most, what they can share is just this 3. This is 2 squared times 3, this is 2 times 3 times 5, and 48 will have its own numbers as well. So again, in this case, what I urge you to do is actually write these down, right? I'm doing these mentally, but what you can try to actually see is what they share in common. Now, remember, 48 is just 16 times 3, so 2 to the 4 times 3. What you'll find is that each one of them has a 2, right? 30 only has 1 2, but 12 has 2 2s, 48 has 4 2s. And each of them also has a 3. They all have exactly 1 3. And then only the 30 has a 5, so 12 doesn't have it, 48 doesn't have it, and there are no other prime factors involved. So the most we have is 1, 2 times 1, 3, which gives us 6. And 6 will be the greatest common factor. It will divide 12, it will divide 30, it will divide 48. When we go through this further, again, 3, we know that we only really need to check whether or not 3 is going to be a factor in either of those because otherwise it defaults to 1. So 30 is divisible by 3, 39 is also divisible by 3, therefore the greatest common factor is 3. And think about why you can't have any factors greater than 3, because right here, I'll give you the hint, 3 won't allow for it. Continuing from here, this is 2 times 11, this is 2 times 2 times 7, and this is 2 times 2. They all share 2, nothing else. 3 times 3 times 5, 3 times 5, and then 2 times 3 times 5. Guess what they share? A 3 and a 5, which leads to 15. All of these, kind of looking at it, will share the 20. Again, we do the prime factorization. This is 2 times 2 times 5. This is 2 times 2 times 2 times 5. And this is 2 times 2 times 3 times 5. So in this case, what we're going to say is that they all share 2 times 2 times 5, so that's going to be 20. 20 will be the greatest common factor. And then over here when we deal with this, all right, so 64 is interesting, that's going to be 2 to the 6. 96 is going to be 2 to the 5 times 3 to the 1, and the other is also 2 to the 5, 3 to the 1. So when you compare those, all they share is 2 to the 5th, which is 32, and we'll leave it at that, right? When we have these three numbers here, this is 2 times 5, this is 2 times 3 times 5, and then this is 3 times 17. They don't share any factors in common or any primes, so we're going to be left with 1. And then over here, again, we think, hey, are these two numbers going to be multiples of 3, right? Because we can't have anything higher than 3 as a greatest common factor because then it won't divide 3 evenly. So 8 plus 4 is 12. That's going to be a multiple of 3. Check. That's done. 3 is divisible by 3. Done. And then 8 plus 7 is 15. So that's also divisible by 3. Done. The greatest common factor is 3.